PB.
Very good, huh?
H2O.
Huh?
H2O2.
Not bad, huh? Not bad, huh? Very good, huh? But this is one thing that I hope you will know, because you are students, you have to know. At the end of this, you must copy that formula, then tell your lecturer this is what you've been through, and then you just read it once and then see how many of your lecturers remember. But generally, for this gentleman here, we don't need to remember. We just need to know this. I like computer. This is nice. This is what the formula is about. Like it? Let's do it one more time. So you saw some electrons moving around, participate, some oxygen moving around, some combination, some hydrogen coming by become water. So there's a stage of eventually become liquid. Not so frightening now, compared to the formula.
Yeah.
It's the same thing, but it's not so frightening now. So we know this thing. Hey, just now somebody asked about valve, right?
Okay.
You asked about safety valve. So there's got to be a valve. So this valve is able to, so that if there's too much pressure, you should open up, release some gas, and come down. No, but if you go to a place and there's so much smell, then something is wrong there. It must be overcharging, and there must be much pressure. Why would there be pressure? Pressure because, like you, when will you have a lot of pressure? And work is a lot. So when you quarrel with somebody, or when someone shout at you, and then you get very heated up. You get angry, right? So there is heat involved. Supposing the room has got, this valve has opened up and then some hydrogen coming, that means something is very under pressure. A lot of heat. A lot of heat you can feel. Why? Why so hot? You can be hot for a while, but if you're hot 24 hours, quite frightening. So if the battery room is very hot, there's very funny smell, and the battery is hot, you feel it, don't walk away. Something is not okay. Check what is not okay. This is important for installers. You don't walk into a room with a lot of smell and you still think that everything is okay. It is not okay. So heat. So now why? So that's why we have a safety valve.
Temperature that's allowed.
The internal temperature under that condition will probably be something like 70, 80 degrees inside the battery. External temperature is only, excuse me, ambient temperature. But the internal heat can be 70 degrees, 80 degrees minimum. Ideally, possible is 100 degrees, more than 100 degrees. Okay, enough to melt the plastic. It's very, very hot. It's extraordinary. Just like sometimes when we have some arguments at home, that's not you, that's extraordinary, only for a short time. But you have argument every time, every day, 24 hours, I think you should stop and find out what's wrong. Same for batteries. So this is a little bit of ideal. Ideally, this should be going on like this. Ideal condition. The battery is charging, floating, there's a float current moving around, very nice. A little bit like Tai Chi. If you cannot remember this, it's really like Tai Chi. Look at the circle. Don't you see it's Tai Chi? Tai Chi balance, yin and yang. Very nice, very smooth, very pleasant. See, you're so nice. Safety valve will not be open at this stage because you are balanced. All kinds of battery. Our objective is to make it smaller, easy, compact, sellable, easy for transportation, easy for sell, easy for understand. Actually, as we progress, you realize that this class is not so difficult. When before we attend, maybe you think that battery is a big deal. But after you realize that it's battery and human beings are like that. There seems to be a balance between the battery and you. It makes you a better person the more you do batteries, because you begin to understand the battery, you begin to communicate with the battery, you begin to realize what is the limitation, what you should not do as a human being, and what you should not expect from the battery as well. For example, if you realize that you push yourself very hard to work for many hours and you rest very little, you're like overcharging the battery all the time. And then you expect the battery to work very hard to give a lot of power and not feeding him enough. Make your worker work very hard and don't pay them. I think something will happen somewhere. Yeah? But if you maintain a balance, it's like getting in love with the battery. It makes you a better person. What are we looking at? Ideally, we're looking at lighter weight, as light as possible. But you must remember there is a limit. Huh? If the person is extremely light and he said he can do the job, questionable. Huh? Okay. Definitely, we have a lot of different and good examples here. You can see this second student. Huh? What's your name again? Sorry. Keith, sure can carry the 100 AH. Huh? 200 AH also no problem. Huh? And what is this lady? What's her name? Denise. Denise should tell you, say I can. But then I think we better maybe better help her. But she sure no problem, I can. So there are limitations. Let us be practical. Not everything is made the same. Battery, you say, hey, this battery is red battery. Actually, all kind of battery has got advantage and disadvantage. The old battery that we realize are the big tractor. The new battery are like sports car. Each has their limitation. The big tractor is very cooling, very slow. They are like a chemical product. The sports car, very high efficient, high power, high speed, very compact, very, very hot. Hey, I just bring a point important. I said something about hot, something about heat. So heat is the one major challenge. Battery don't like heat. Just like we don't like to work in a heated environment, we like to have a balanced environment. So the first enemy of battery is temperature. Okay, what is the ideal temperature? Ideal temperature is the balance of temperature. That means the room temperature should be as balanced as possible. The hottest point and the coldest point should be less than 5 degrees difference. Okay. Ideal temperature should be as close as this room temperature, which is about 28 degrees.
Ideal.
Ideal. Huh? To say that you want 25 degrees, I don't think it's necessary. Ideal is 28 degrees. Okay. Where is the limit that many battery, many power systems they set? I think they set at 30 degrees. Okay. Why 30 degrees? Because 30 degrees is quite close to what is in many places outside, about 32 to 35 degrees. So ideal temperature is 30 degrees and below. Okay. Then Peter, what will happen if I put 16 degrees? Nothing will happen except that your boss will fire you because you waste electricity.
Battery will leverage, right?
Battery will nothing go wrong, huh? But you will lose your job because you're wasting electricity. What if I put the battery down all the way to, hey, what about snowing? What will happen? In some cases, some country, minus degrees, -2, -3. What happened? Cannot. Did we mention that there was a thing called electrolyte in the battery?
Okay.
So that's probably liquid, right?
Yes.
So below negative, what will happen?
Freeze.
Huh? So the performance of the battery will go down. Because battery works just now from the formula that we remember, it's actually an effect called recombination. You transfer from one energy to the next, and then you recombine and you give out and go backwards, forwards. But if the liquid, the electrolyte is being frozen, then I think the exchange will be very inefficient. So negative temperature, there's a limit. Up to a certain place, the efficiency definitely will go down. So in order to compensate against this, usually we will charge a higher current to create some heat so that we will balance the inside. We have covered a few things. We have talked about the material. I think material is also important. Okay, we cannot use too cheap material because it can crack. Okay, we have also covered something that about the grid. So there's some plates inside, positive, negative plates. That means the quality of these plates also will affect the performance of the battery. We have covered something about electrolyte. Too little electrolyte, there's not enough chemical reaction. Too much electrolyte or too dilute electrolyte, it will also reduce, it will also evaporate. So electrolyte seems to be an important factor. Okay, frozen. So ideally, if let's say the electrolyte can be released or reduced or evaporate lesser or slower, then the battery life will improve. This is the reason why sometimes we put some chemical to this electrolyte. For example, we put a silicon SiO2, silicon dioxide, to make the electrolyte a little bit more like gel. Now you realize that sometimes you have some batteries, you crack open, it looks a little bit like gel. Okay, so it's also electrolyte, but the electrolyte will release slower. So we call this reduced water loss. Reduced water loss will enhance the battery life. But too thick, totally no water, the battery is like frozen, the electrolyte is like frozen, so there can be no power. So too liquid, there will be more chemical reaction, but the electrolyte will finish faster because too much heat. Now, it seems like I go round and round the same thing, but I'm almost talking about heat. I'm always talking about acid. That is a chemical product. So that means there's also acid can dry, there'll be acid powder. Maybe this is the reason why sometimes I look at my car battery, there's some white powder, there's some yellow powder. This is called acid stratification, dryness. So we also know that the objective at the end of the day is to give more power. More power means thicker plate, means bigger battery, bigger size, higher, heavier, and more chemical reactions. Okay, so it's a battery. On top of this, we also realize that cooling is important because I mentioned many times during this 20 minutes about heat. So it is important to maintain a cooling environment. The cooling environment is to balance a good flow of heat, or airflow, sorry, good flow of airflow in the surrounding. That means the cabinet that we put the battery in is very important. Okay. Do you realize that there is a battery cabinet in this room? So James, maybe you want to open up and let us take a look at the battery. Okay. The system that you're going to do is big, much bigger than this, but there are also some small systems that you need in masses that looks like this. Am I right? There's 24 pieces, each piece is 2 volt, each piece 2 volt cell, and then I think maybe this one is probably 400 AH. And then you have a rectifier, and you have breakers, and you have some cables and some distributions. The size is about this size. Am I right? Some of this was in masses. So you realize that just now James opened up the door. Then earlier we closed.
Yes.
So when we close, we call it trap heat. Now we open up, of course, it's aircon and it's very cooling. It's very nice. But you cannot do this always, right?
Yes.
You do this open, then tomorrow the battery will be gone.
Yep. Not tomorrow, after 1 hour.
But if you close it too much, then you realize that there's this thing called rectifier or something like this, which generates heat. You also realize that probably the heat is not balanced in this cabinet, so we need to balance it. So we probably have a ventilation fan to create the airflow. So it's all about airflow. The trick to good battery and enhanced life is to achieve airflow, balanced airflow. If we put a lot of pressure on one cell, you realize that the challenge is that this 24 cell work has a team. Supposing I load this guy heavily, he give up, every one of us is out of the game. So it is important to work as a team. Now, this is getting interesting. Learning about battery seems to be teaching you more about life, about working as a team, about balance, about being fair, and so that you do not overload him all the time. This is a reason why we never let him go back. If not, he finished 1 hour, he means he's very good. It's not all the work go to him. So we need to have a balance. Is that good enough? Okay, let us go a little bit faster. So if we were to have a good team, then we don't need to have so many skills. We can balance our skills and share our knowledge. So sharing of knowledge is important. Reduce diagnostic experience. Now, Peter, can we have a little bit more balance? Not so high quality, not so low quality, not so expensive, and yet cheap. Hey, hello, you pay peanuts, you get monkey lah. So let us try to make a balance and be practical. Practical to your needs and your environment and your site. Maybe instead of having a tractor, too lousy, too noisy, or a sport car, too hot, too powerful, maybe we drive a saloon will do. So this is also important. So this is all about different battery, different price. But the most important is about applications. I think we can go much faster because this class is very clever. We have already come up with the alloy. We have done about electrolyte management. We have talked about being positive plate, plastic. Then we talk about thermal management. This seems to be all the important things that will make the battery good. But I've added one point, which is called the asset management with RFID tags. What is the reason why I added this point? Because I realized that nowadays battery very interesting. The person who you install the battery tomorrow, if you don't take good care of it, the battery can disappear.
Yes.
So we got asset tracking. I think not in Narada, but in the system. Okay. I think in the system of Orissa Wacom, they have also added something like this. Why I tell you is because so that you know that this battery is being tracked. Don't bring them home because after that you realize